My name's Hans. Nice to meet you. Hope you've all been having a good day. First, I'm going to talk a bit about how I got here and what I do. Oh, this is not really behaving very well. So I am a test engineer at the Binar Space Program. I started at Curtin doing mechanical engineering and commerce double degree. Last summer, I did an internship at Binar and made a machine that winds some electromagnet coils for the satellite. Then I completed that it started as a casual employee at Binar and completed that over the rest of the year. And graduated or finished my degree just this semester, and here I am as a real employee, a full-time employee of Binar. So I do a lot of the testing and helping with mechanical and hardware in the lab. And I'm a bit of the go-to CAD guy, or 3D modeling, whatever you want to call it. So that's what we're going to do today. We're going to look at what 3D modeling is, why it's helpful, and how to do it, and some best practices. And then you're going to have a go at editing and making up your own rocket nose cone for the rockets coming up. So, has anyone used 3D CAD before? 3D modeling? Yeah, we've got a few. Okay. Yeah, nice. What software do you guys use? AutoCAD? Blender? Yeah, okay. Blender as well? Yeah, right. So today we're going to be using Fusion 360, which is Blender is a surface modeling type of 3D CAD, so it creates like more organic shapes and surfaces, and Fusion is a parametric 3D CAD. So what you do with that is you kind of tell the computer exactly how big and what kind of shape parts are going to be. So you end up with parts that are good for a lot of engineering purposes, but can be hard to make kind of organic shapes or ergonomic stuff like you'd be doing in Blender or doing some certain types of modeling. So in engineering, 3D CAD lets us make accurate virtual 3D models of our designs. So anything from just an individual part to a whole assembly. You can kind of see that there is multiple parts in a small assembly that are going to be part of the rocket. But it could go up to nearly anything you interact with that's been manufactured today will have had a CAD model made of it at some point, which is going to be a massive file assembly with a whole bunch of all the parts that make it up. This also lets us simulate and test the virtual models. So there's limitations. It's not quite as good as actually going out in the real world and launching a rocket, for example, but it's a lot cheaper to test something virtually, a lot cheaper and quicker than to build it and make it and then find out that it needs additional changes. So that's why a lot of initial simulation is done in CAD so that we can make sure our designs are hopefully going to work. We're pretty sure they're going to work before testing them and making sure they work. It also allows us to visualize and share the designs with other people. So for example, today I was just over in one of the rooms over there. We had the design for the Binar 234 satellite, which we shared with one of the technicians who works here at Curtin, and they did some testing on it to make sure that it's the size of how big it's actually supposed to be. That would have been not quite impossible without 3D CAD, but it would have been a lot more difficult. So that is one of the benefits of, some of the benefits of 3D CAD and what we can use it for. Oh, wrong way. So how does parametric 3D CAD work, 3D modeling work? So it's basically just making a 2D sketch of something 2D, and then using tools to make that into a 3D shape. So there's quite a range of tools that we'll play around with a bit today. And yeah, you end up with a part, then you can do additional features and sketches to add more parts to that. And then at the end, yeah, you can export the part for 3D printing, like we're going to do a bit of today, or simulation and manufacturing, drafting if it needs to go back into a 2D file at the end. Yeah. Any questions so far? So some of the best practices, I think there should be a video, yes. I'll make that play. Some of the best practices for parametric 3D CAD, this is really the main one, is fully constraining all your sketches. So what that means is dimensioning or constraining the part so that everything is locked in place. So you can see on this part here, I think, this is not fully constrained. So the parts move around and are kind of not locked in place. And to fix that, we'll go through it today. This is a constraint to make that a tangent, and then I say how far it is, how tall it is, essentially. So it's important to ensure that everything's always fully constrained. Otherwise, you can go and accidentally make a change that you didn't intend to make, and it can be hard to get back to the thing. Dimensioning everything to a reliable feature is very useful. So the origin of your sketches or parts is kind of the middle point or the beginning point. And that's really locked in space. Whereas if you were to dimension parts to maybe another edge of the part, then if that edge moves later, then the initial part is the second part is going to move as well. But that can be useful depending on what the design intent is. So I don't know, for example, for this rocket nose cone, you might have a diameter measurement, which would say this is, I don't know, 50 millimeters or so in diameter. And that could be correct, could be the correct dimension, but more important in this case is that it matches the diameter of the other parts. So that's what this dimension here shows, is it's actually locked and constrained to the diameter of the other parts. Alrighty, now we're going to get playing with some CAD. Can you
straight?
I'm not sure. It depends which type you're in. So if you hover over that
Line.
yeah, if you go line, should be straight. Huh. Try that. Just try make it go all the way to the end and see how it looks.
All the way down?
Yeah, just make it go. So you have to make it connect from that point to this point. Oh no. How you going? What's happening?
It died.
Oh, Fusion died, did it?
Yeah.
Do you want to use one of the computers?
Once I get back up, it should.
What?
It might
I can make a straight line going this way, but not this way.
It maybe depends on how you started your line. So if you ESC and exit that, if you hit it, ESC, just hit ESC. Should let you get out of that. And you can delete those or Control Z those. I think it should depend on how you started the line. So if you go line and then.
Back in here, and now we see.
Oh, it's because I think it's because you're dragging. So if you just click. Yep, and then up. There you go.
Oh yeah.
Yeah. So I think dragging. See how it's line and a tangential line at the end. So if you drag, then it makes like an angle.
What do you say the most aerodynamic thing is?
Well, you can look that up. It's some funky kind of shape. So look up nose cone aerodynamics. Yeah.
And so now what we want you to do is
Okay, let's put that right.
shape of the nose cone to make
That's the job.
Design.
so you can do like whatever shape you want. It'd be nice if you all make them a bit different.
I think there's a specific
And so if you just want to
shape that's the best. Well, there's no specific shape that's the best. The specific shape that's the best at the lower speeds that we're doing here. So nose cone aerodynamics comparison.
I put wings on mine, but I think they're going to snap off.
Comparison.
Yeah, try that.
Maybe a good rule of thumb would be like, if you look at the fins on the rocket, you probably want the drag on your nose cone to be maybe like half of that.
Parabola.
Percent of drags, percent of flat surface drag. Interesting. Yeah, okay, so a parabola is the best.
We got people looking at the most aerodynamic.
Yelling at me anymore.
So to make, how do you want to make that? Okay.
I don't know. Parabola.
Parabola, low drag.
Yeah.
Yeah. So kind of just maybe start playing around in Fusion and see if you
I think
can.
that is a parabola. Wait, if I
Well,
make
yeah,
it straight on
it shouldn't be straight on the end, exactly. It should be. So you might.
I'll make this higher.
No, because that'll have to be all. It depends on. So
That'll
a
be
parabola has to be tangential at the end. So what you might try to do. So when you're constraining the parts,
Yeah.
you can do dimensions or you can do constraints. And this one might be good to have if you go constraint, you go here.
Where?
Yeah, that tangent constraint, that one with a circle. If you go that and then click that and then the one above it, just the little orange one.
I got the rules wrong. So
Oh, now see.
Is that one?
if they're in here, they need to be up on the shelf. And if you want to drink from them, you need to go into the hallway.
And then see if you can drag that down now.
Because outside.
Just ESC again.
So
ESC. See if you can drag this point, this corner. No, you don't want that. Just Control Z.
if you're in home, I can remember how we saved it. It's there. So team members with
Okay, so what you might need to do is create an ellipse. I think this might be. So a parabola is not a continuous radius,
Yeah.
right? Like it gets sharper. And I think what we've got here is it's like a continuous radius of a circle. So if you go back to Fusion, if you just delete that one,
I don't want the payload
now go into Create,
dealing with the nose cone,
Great.
right? That was what he said.
drop down there, do the drop down of Create
Wait, drop down where?
in the just here.
Better to use it again with the mouse.
Now go, maybe try arc. It wouldn't be an arc. Must be an ellipse, I guess.
Sonic curve.
conic curve.
I'm not sure what the shortcuts are.
Yeah, it could be conic curve. I don't know how this
I'll let you do
works.
it from here based on the markup, because that is how you
Oh,
at least it's working.
okay.
So it
Maybe
doesn't let you edit. You
Control Z and retry that, and go to the very end. So what I would, so try go, conic curve. So go from that one, yep, to the end on this one.
No, it's not like that, because then
Yep.
this happens.
Well, if you go, what if you go down a bit? If you go like, if you put your mouse like here,
Then, yeah.
and then if you take this guy down, make that shorter, then it might look better. It might, because it's currently set to be a.
Like that. Like up a bit. And like,
Yeah, I think you've got to go to the.
like halfway.
I think you do have to go to the end, and then you change where the middle is. So it's, you do the end points. So you do the end point, go to the end. Yep. And now come to about here. See, that's getting more parabola-y. Down a bit, maybe? Yeah, maybe, I don't know.
Maybe like there.
Yeah, try that. And then we can say 1. See what that does. Oh, doesn't like that. 0.1.
Like that.
Yeah, but I'm not sure what that's. Can you edit that? I'm not sure.
I'll try a
You could do. You could do a. Where is it? You could do a spline. So this one up here. Next one. It's the one next to that circle. Fit point spline. So you could do that. And then, yeah, click the end. This is what you want. Now ESC. Just ESC. Oh. Alright, then try that. Do the spline and then tick instead of. That's the one that's constant radius, I believe.
Okay, just keep working through the markdown, everyone, once you're ready. No rush. Play around, get familiar with the interface. So, you guys all have the...
Let me know if you need any more help. Just try around until you can get one that I think the conic curve should work, or the spline should be able to get something. Both of them should be able to get something that works.
I'll just wait. Here we go.
Go on.
All right, listen up, guys. I've just got something to go over, which
Oh.
is kind of fun for context. You guys all have your rocket kits in your bags, right? And that's got the standard nose cone and
The yellow one.
the yellow and green one, which Robert just didn't like the color. And it also wouldn't fit the circuit board. So Robert designed and 3D printed custom nose cones and supports for the PCBs and threaded inserts. So you guys are going to customize your own, but that's how that goes together like that, and then fits within it. So that's what you're going to be printing is this part here, and then this is it when it's all finished and painted, and has everything in it. So you're going to be able to fully customize it, but you don't have to just have it aerodynamic, even if you do want to win the most aerodynamic flight award. You're going to go in later in the markdown into Thingiverse, and you can customize it with whatever you like. So if someone was walking around with a box full of D&D miniatures, I think they've gone. Yeah, but you know, this is your opportunity to be either super technical and precise, or get creative and artistic. So
I really want to see one with like a figurehead, like a ship, you know, like with like a mermaid on the front, or like, I don't know. I kind of want to make my nose cone that's like a fist or something, like powerful rocket.
like
or something.
Superman.
Yeah, like Superman.
Superman fist. And so you'll see later in the markdown, Will's added a link to Thingiverse. If you've never been on Thingiverse, it's a very, very deep rabbit hole to fall down because people all over the world have uploaded their own models to that. And you can print all kinds of really cool stuff, or you can do what Hans does, as he's the most organized human that I know, and print custom tool supports and desk organizers for our lab, and keeps everything very in order. I think I went down the other day, and you'd actually printed positions for AA batteries to individually stand. So you can use it for however you like, but get stuck, because that I had so much fun with it, and I can't wait to print something.
They were sitting on the desk for over a year, so I said that's enough.
All right,
The
with
double
the
batteries, they were sitting on the top of the desk.
So I'm sure there'll be an award for like the most.
Oh, there you go.
Yeah.
Perfect.
Color.
Definitely. So you get most
Payload sketch.
aerodynamic, and
So
then
construct
probably
clean
least
it.
aerodynamic.
Oh,
One thing to keep in mind.
I'm not. Oh, hold up. Go back to that.
To the top level of
You go back to that website.
which I think is called Green Eggs
Fusion
Rocket
360.
with Simple
maybe
that there's
try.
a long rod next to your rocket? That's the launch rod, which, while the rocket is getting up to speed, it stabilizes the trajectory of the rocket during launch. So we are going to need to put your rocket onto the launch rod, with a
Yes.
fancy word for a little paper straw called the launch lug. So if you design a nose cone that's really wide, that's fine, but you are going to have to figure out how to make room for the launch rod to go up through your
Could have-
nose cone if it is really
Could
wide.
have dual support, so you have
Dual
the
support, you actually put it
and just
through
support
here.
it through the nose cone. Just a hole in the
Oh
nose
yeah,
cone.
so probably the best way to do that would be to add like a tunnel through your nose cone, like a hole.
Yeah.
That is kind of complicated. You'll need to do that before the shell operation. The other way is you can put like a slot or a cutout. But we can help you with that. So don't let that hamper your product, your creativity. Just be aware.
Yeah.
So
So if you go,
This is what is the actual printer.
Fine, where's the
Once you
pressure
create
sensor
your
group?
3D
Put your hand up if you're a
model.
pressure sensor. Pressure sensor people, who's doing that? Pressure sensor. Okay. You guys probably want to put some holes into
because that's a
the air
sketch.
pressure can
So
equalize
maybe look up how to do this one. How to use conic curves.
like lower pressure, but we might want the air to
Video,
escape
alright.
from the nose cone. So the holes don't need to be large, but they do need to be there. Now we do have an added complication. So I'm going to put the 3D printer on in a minute, and you'll be able to see how it works. But basically, if we wanted to make a shape like this, it prints down layers, kind of like just imagine.
Okay, so I saw a bit there that could be useful. So what you might be able to try to do is if you go back into here, so delete this guy, and I want you to, alright, well, how do I do this? Make a line going from here and then all the way across.
Once it gets to the top of the hole,
Yeah, make it, and then what do we want to do here? We want to dimension that. The dimension, yep. And just click on the line.
put your holes into the part
So and then yep, make it I think 40 millimeters. So click,
at your
click there, and then say 40.
payload adapter. If you look at
Is that halfway?
can't see very well.
No, it's not. 44 maybe.
The holes in there are actually little
You
teardrops.
can measure it
So
and make
if you
it
have your nose
correctly.
cone like this,
That looks maybe more like
instead
it.
of putting a hole like this,
So I
I
want
would
you to
actually put in
click on. So I think you have to select this.
Yeah, you can kind of see
S.
the circles there,
Yeah.
Robert.
a few smaller holes.
You're gonna have to
kind of
exit
like
because you're still in
teardrops shapes.
still in
Because when you have that 45-degree
in
angle,
dimension, and then yeah, now click that and make it a construction sketch. So what we're going to do here is we're going to use it's at the top.
yeah, and
Yep.
I would put your for the
Yeah.
pressure sensor,
And
so that you
now
don't, like, force
try
it
the
to
conic curve again.
result in like a erroneous measure,
Yeah.
not like too much pressure.
Conic curve.
I would put them on a section
Now that guy.
There
and
to
I'd probably
there.
put
to
Yeah,
there, yeah.
exactly. So there
down the bottom.
to there,
Um,
and now just make it up all the
just
way.
so that the pressure
Up, up,
inside
up,
the
up,
hole
up,
is
more,
close
more.
to the pressure
Yep.
outside.
You want to because what we're going to do, we're going to constrain it after to make it bigger. Yeah. So you go like that. That's good.
So what it might be
Just
worth
click
doing is
enter.
There's 4 of you, right? Maybe have different
And now we can start constraining it so it's a parabola. So yeah, so that's now clicked on that. I think so. If you drag the end again, it should they both naturally move.
a tube,
Hmm.
inlet and an outlet.
Neither of them moving now. Interesting.
Then
No, that's okay. Don't control Z. Just see what.
the pressure sensor is in there or something.
Alright, try now the tangent one again.
That one.
So this guy,
And I'll come around
and now these two ends, because you want it to be a smooth transition, right?
These two ends.
Yeah, those two lines.
So the yellow nose cone and the green tube in your pin, you can just put in the bin because we're not going to use them.
Interesting.
Just please be careful
that
with
one,
these
yeah.
because they won't break
Doesn't like
easily.
it.
They take a really long time to print, so no chucking them around. But I'm bringing you your 3D
Hmm.
printed payloads.
Alright, I think that's the. What if you try to drag this? If you get this line, this one and drag down.
No, they're just going to
That's what you'll mount the microcontroller board.
Hmm.
Batteries.
It's not quite what I was aiming for. Conic curve, I think, is the right way to make a parabola, but it doesn't seem to quite be doing what we want it to do here. Just keep on looking. Okay.
How do you like scroll down?
You can, if you press the back button, if you press that, I think it should, it'll go to home. Movement is shift or control. and then moving the one of the things, maybe the middle mouse.
I got a design.
Oh,
I'm just trying to
try the
make
other
it
one.
work properly.
Try control then. Control and middle mouse button. There we go.
There we are. Make sure those stay in your bag. You don't want to lose these. Here you are, Dylan.
How you going?
There you go. John, right? Yeah, or just grab that one. And I'll come around with the other bits
So I
as
think
well.
that's.
So you just keep trying
So
to
you've
keep,
edited that. Whoa, yeah, there you go. Yeah. So if you double click that, it'll start editing it.
Yeah.
And then if you accidentally click one of these, it'll add that. It'll say, make this radius the same as this distance, and that'll make it really big. Right. Yeah.
Yeah.
but you don't have to.
Can I use this one? Last 3D that.
Yeah. So we'll 3D print.
absolutely,
Yeah.
but you're gonna add some cool stuff to it, right? Awesome. Here, Dylan. So this is a default notepad, and Will's coming around with the faces. So we're gonna put all these together, but for now,
How you going?
please use them to measure the plates and diameters.
Good.
Size it to this.
So how you might want to do that? You want get the same diameter. Is that what you're trying to do?
Yeah.
So what you can do for that, there's a couple ways. With CAD, there's a lot of ways you can do like the same thing. What I would recommend would be to go into your sketch up here,
Yeah.
and I would say you'd want a constraint coincident, yep, of the end point of your line and that purple point at the top corner.
This one?
Yeah. Oh. That's not how I expected that to do that. Just Control Z for a
These
second.
are the nose cones that are the ones that are the originally 3D models. So if you do want to use those, you can, but you don't have
Is there another line at the end of that? Is there 2 lines there? So try dragging the end line.
on there. So you
Oh, there might
Drag
be.
the end
There's
point.
a tiny one there.
Is there one there? Okay, because that's just joined them together.
you are Dylan.
Oh, okay.
If you,
Whoops, sorry, I'll just
Alright.
squeeze in. Oh, I'm still working on names. Rogan.
Yes.
Grab a nose cone. So these are the ones that are the default ones, but you're going to make your own. But while we're doing our measurement of parts for trajectories, it's good for you to have something to weigh and measure.
Sure.
And then we'll modify it based on what you design.
so there's a couple ways you could do this. You can get those to click together. You could try it again to the end one. Yeah, that. Try that. Oh, interesting. There must be another line there. So just try to delete that line. So select the line that's created there.
This one.
Not Control Z. Oh, you can try to delete that. See what happens.
That one.
Yeah. Now try that again. So try again, coincident.
I did
There we
that
go.
wrong.
It's better, but it did go down to the bottom, yeah. So yeah, go again. So if you do you want the end of the line. You go coincident again.
I think it was on my phone.
End of the line to the top. Yeah, to that one. Oh, why is it doing that?
Like,
Try. I
for
think
some
you.
reason it's going to the.
I think it's going to